So welcome back. In today's video, we are going to look at a nice concept, two nice concepts. One we are going to look at functional interfaces, and the other is going to be called Lambda expressions. So we saw what are interfaces. What are interfaces? Simply, interfaces are like blueprints of creating something. Like you say, class. A class is also a blueprint, but an interface is something similar. But the difference with an interface is that you are not creating the actual thing, yet for the class you are creating the actual thing. So simply an interface is like a design for creating something. So today we are going to look at how to create interfaces, but specifically for functions. In the previous videos we saw how to use like variables and other things, but today we are going to look at specifically functions. So what if I have an interface interface now in this interface, let me say it's called, now this interface being called A, it has a method show method which is returning data type of void. So in this is our method that we have in our interface. So to display this in our main function or main method, you will come, you see, you will come new is equal to, let me say I'm creating an object is equal to new a you see that this let me say I want to try to access the object let me say I want to access the show. You see that this is not allowed here because behind the scenes an interface is just simply a design, not the actual thing. So you can see that we cannot create a new instance for this interface in this case. But behind the scenes, what Java does is that it treats this interface as a class, but it is simply not the actual class, but behind the scenes, it is a class. And to prove that, when I try to uh, compile main.java, when I try to compile, you look at this side, what they are going to do. They have created a class for A. This interface, they have created its class, but we are having an issue here. So I can clear this. So let us solve this. So to solve this, we have two things. First of all, you can decide to come and create a class. Let me say this is, and this is B, and this B is extending. Oh, sorry. And for interfaces, we don't extend, we implement. So it implements attributes of A. So being that B is implementing attributes of A, you can see that automatically after putting implementing, they want the show method. So I'll say void, which is our data type of show sorry, show is system.out. This is our show. This is our show. So you can see that oh, we are having here, so it is not this visibility, so I can add here public. This is a public class, so something like this. So instead of creating an instance for A, this can automatically change to B. This can change to B in this case. So you see that it is accepting. So when I try to compile again, compile and run Java and run, you see that I'm able to access the show. This is our show, which is this one. So if you take note, you can see that we have created an extra class, but I think this is not okay. This has worked, but this is so hectic. What if we create something called uh, what if we create something we create an anonymous class? So instead of doing this, I can first comment out this. So instead of doing this, I can take this back to A and this back to A. So instead of this, can we create an anonymous class like this? You come here, outside, you say open brackets, you say inside this I'm having my show, my void method, which is show, and in this show it is printing out system dot print out. This is our show. So I have created an anonymous class, or an anonymous method inside our interface, but this has to be public in order for this to be accessed outside. So we can do this instead of getting another extra class. We can use an anonymous. I already have a video explaining how anonymous classes work. You can go and check it out. So we can do something like this. So this will work as intended. Let me first clear this. Compile, compile. You can see that they have created, being it is an anonymous, they are saying that inside our main we're having one anonymous class, which is interesting. So compile and run. You see that this is our show, that it is our results are coming back as we intended. So this takes us to another nice concept called Lambda expression. This is still, but before we go to Lambda expression, here in our interfaces, remember in the previous video we saw how to deal with annotations. So this, to define this also has an annotation which is called up here. I can say at functional interface, which this means that in my functional interface, this one that I have created, it is expecting one method. So automatically when I put two, when I have this functional annotation, it will tell you that, oh, human, you have said that we are expecting one interface or one method, but you are putting two methods. So this will help you to solve particular problems. But this is still Java 7. This, all of this was done in Java 7. But later in Java 8, they introduced something interesting called Lambda expression. Being that this code, the one that we have written, it's detailed, which is okay. Having your code detailed, it's okay, but take an instance that you are working on a bigger project. uh, you having a detailed code will make things uh, more worse than you expect. So in Java 8, they introduced something interesting. They introduced something called Lambda expression, whereby they wanted to reduce the lines of code that was written in Java, specifically in this line. So what are Lambda expressions? So, or how can we implement Lambda expressions? So are you seeing this here? You know that in my class, my A class, after creating an instance for this, you know that inside this we're having the show method, which is picking which is getting it from this side. How to implement Lambda expression? Let me explain this again. We already know that our interface is having a show method having a data type of void, meaning it is not going to return anything. But again, we are coming down here and we are defining the show method again. So in Lambda expression, what Java did is that we want to reduce the number of code that is written. So how can we express this? So I'll come remove this also, come remove this extra bracket. So come up here, put these two uh, brackets. So do like this and make this a single line. You see that. So this is what we call as a Lambda expression. I have removed all the unnecessary things and remained with one line of code here. Simply with the Lambda expression, you see, even this is not needed. You see that it is very possible for me to do what, to create this show and return something like this. So when I come, or for those who are somehow behind, what I did is that, let me take this back. what I did is that move this. So what I did was that, remember this, we already have the show method defined and we already know the data type, being that it is a void. I'm going to remove this up here, remove this, come down here, remove this, and being that we are not creating a new instance, remove that also. So you use this expression, this one. So automatically after doing that, you will see that we have remained with one single line of code. Let us see. I think everyone is asking, will this work? Let us try to see. Java compile and run the code. You see that our show is working as intended, but simply by using this expression here. So what does this do? This is going to look at in our show, in our interface that we are referring to as, and automatically after looking at our interface, remember our interface is saying that we are having one method, which is the show method. So we shall use this expression here to return out our output, but simply through our show method. So either if I remove this and try to compile and run, you will see that we are not getting anything back simply because clear, simply because what Lambda expression does is that it goes into our interface, which is our functional interface. It looks for our show method. So inside the show method, it is saying that we are having a data type called void. So what is this Lambda expression does is that it is going into our show method and it is going to return this on besides of the show method. So it will be something like show to be like show show system dot out. Then you put this statement. So this is behind the scenes what Lambda is doing. But instead of doing that up there, it is simply using this expression down here, calling our show method and returning this statement here on besides of the show. So anytime that you call show, this statement is the one going to be called. Being that we use this annotation of functional interface, even if I try to create the second one, let me say show2, it won't accept, being that you are saying that we are expecting one method and we are using two methods, meaning in all cases this show is going to return this. So that's simply what we refer to as a lambda expression. But what if I'm having this show and it is taking in arguments? Yeah, nothing changes much. Just you have to come tell this show that I'm expecting an argument which is of data type. You have to define the data types, which is, let me say, I in this case. So in this case, what you do that you come here inside your brackets, you say that we are expecting an I, which is our argument that is coming in. So instead of this, I can print out the I can print out the I in this case. So you see that I'm passing 5 as an argument, I'm receiving this, and I'm also doing this. I'm also receiving it down here, so I'm printing it out in the same line. So when I compile this, compile and run, you see that 5, this is our 5 is coming. So if you have like 5, what you can do is that not remove this row, but everything remain the same. So the other thing I can talk about, if you have like multiple lines you want to print, what you can do is that you can cut this, put these curly brackets open, so you can put multiple lines in this case. Yeah, you can put multiple lines. You can see that when I compile this, this will work as intended. So today we have looked at functional interfaces and lambda expressions. Thank you.